Right now, somewhere above you, an eagle is watching. Not in a metaphorical sense, literally. There is almost certainly a bird of prey somewhere in the sky above your region that can see a rabbit sitting in a field from 2 miles away. In detail, not a blur, not a shape, detail. And that's the simplest version of what eagle eyes can do. The version science discovered first. By the time researchers understood the full picture, the results were strange enough that one researcher described it this way. Compared to an eagle, we are functionally blind, not visually impaired, not limited, functionally blind. This is what they meant. Start with the numbers, because the numbers are the first shock. Human eyes contain roughly 200,000 photoreceptors per square millimeter. These are the cells that detect light and convert it into the image your brain calls reality. 200,000 per square millimeter sounds like a lot. An eagle has over 1 million, 5 times the density, packed into an eye that, proportionally speaking, is enormous. If your eyes were the same size relative to your skull as an eagle's eyes are to its skull, they would be the size of billiard balls. You would not be able to move them, which incidentally is exactly the situation eagles are in. Eagles cannot move their eyes in their sockets. That might sound like a limitation. It's not. It's a design decision, because eagle eyes are not built to scan like yours are. They're built to lock, and the structure that does the locking is something called a fovea. You have one fovea in each eye. It's a small pit at the center of your retina, the highest resolution region of your visual field. An eagle has 2 fovea per eye, 2 separate high-resolution processing centers orientated at different angles. One points forward for binocular depth perception, one points sideways at roughly 45 degrees. And those fovea are not flat the way yours are. They're concave, deeply concave. The curvature acts like the inside of a telephoto lens. It magnifies the image before it even reaches the photoreceptors. Evolution spent millions of years building a zoom function directly into the physical structure of the eye. The result? An eagle's visual acuity is estimated at 4 to 8 times greater than a human's. In clinical terms, where human normal vision is 20/20, eagle vision is closer to 20/4. That is the measured resolution at which their retina processes light. From half a mile away, an eagle sees what you would need to be standing 10 feet away to see. Here is where it gets strange. You are a trichromat. That means your eyes contain 3 types of color receptors called cones, each tuned to a different wavelength of light. An eagle has 4. The 4th cone type is tuned to ultraviolet light, light that exists outside the range of wavelengths your eye can detect at all. Light that is, from your perspective, completely invisible. Eagles see it, and the world viewed in ultraviolet looks nothing like what you know. Rodent urine glows in UV light. When a field mouse moves across an open field, it leaves a trail, a luminous path in a frequency you cannot see. An eagle doesn't just see the mouse. It sees the mouse's recent movements spread across the landscape like a map drawn in light. Flowers that appear white or yellow to you have intricate UV patterns on their petals that birds use for navigation. A meadow you would describe as a field of green contains visual information an eagle experiences as something with no human name. Color, for an eagle, is not a simplified shorthand for reality. It's a richer signal than anything your brain has ever processed. And even within the colors you can technically see, eagle perception is sharper. Their cone cells contain tiny colored oil droplets, 12 different types, that act as filters, narrowing the sensitivity of each cone and boosting contrast between similar shades. The difference between 2 shades of brown that look identical to you, same fur, different species, are distinguishable to an eagle from half a mile away. This is how they hunt. Not just with resolution, with color information your brain has never had access to. The next time you look up at the sky and see nothing, remember there is almost certainly something up there, seeing everything. The sky is never empty. You just cannot see what is in it.